Hi guys, this is Kumar and today we'll be studying how to use divisibility rules to solve a question. For example, let's see here. So we have been given a number 62AB427. Obviously A and B are unknown and we know that this is a 7-digit natural number which is a multiple of 99. Okay, and we have to find the value of 950A plus 29B plus 1. So the techniques we'll use to solve this question are divisibility rules, especially of 11 and 9, and then we'll solve simultaneous equations to get our final answer. So before we start, we have to understand what are the properties of digits that we have to take into account to check whether our answers are correct or not. For example, A and B, they are digits, right? So basically they have to be whole numbers and they have to be between 0 and 9. So if we get a value of A like 3.5, that is not correct. We cannot accept that as an answer. We cannot accept even negative answers or answers that are greater than 9. Alright. So now that we have understood what the values of A and B can be, let's start with a question. The first principle that you have to understand, that if any number is divisible by a number n, it is also divisible by its factors. What this means for us is that the number that we are dealing with, it is divisible by 99, right? It also means that it is also divisible by 11 and 9, which are nothing but the factors of 99. So what we'll do, we'll check for divisibility test of 11 and 9 to find out whether we can find any relation between A and B, which we can then use to solve the values of A and B. Okay. So the divisibility test of 11 says that the difference between the sum of digits at odd and even positions has to be a multiple of 11. Let's see this in action. Our number is 6, 2, A, B, 4, 2, 7. Alright. Now what are the numbers at odd position? See, 6 is at position 1. Then you have A at 3, 4 at 5, and 7 at position 7. Right. So the sum of odd position is nothing but 6 plus A plus 4 plus 7, which is 17 plus A. Okay. And at the even position, we have 2 and B and 2 again. So the sum of even becomes nothing but 2 plus B plus 2, which is 4 plus B. Okay. Now we have to look for its difference. Alright. The difference between the positions, sum of digits at position odd and even, is nothing but 17 plus A, and you subtract from that 4 plus B. And the result that you get is 13 plus A minus B. Now this is the number that we have to find. We have to check for what values of A and B this becomes a multiple of 11. So we'll start by looking at what our options are. And you have to understand that there will be not a lot of options because we have limitations on A and B. Okay. So rather than A, let's just write this as part 1 to avoid any confusion. So the nearest multiple of 11 that I can think of near 13 plus A minus B is 11, right? And for that to be, I need my A minus B to be equal to minus 2. Now some of you might worry that if having a negative number is okay. See, it is perfectly alright in this condition. We mentioned that A and B have to be whole numbers. So they are positive numbers between 0 and 9. But B can be greater than A, right? So you can have A which is 3 and B which is 5, or A which is 4 and B which is 6, which means this condition is perfectly alright. So we'll call this our equation 1. Alright. Let's see. Other option can be this value being 22, right? That will happen when A minus B is equal to 9. Now see, this is also possible under a set of condition where A is 9 and b is 0. That is, I think, the only condition in which you'll get a minus b equal to 9 with a and b being digits. All right. Also, you have to notice that the reason a minus b is having different values is because they are different set of values. Okay. We can have a 4 and a 6 for a and b, and a 9 and a 0 for a and b. So these are different set of values that still satisfy the relation that we are testing for. Suppose if you look further, what if I want to check for 33, right? In that case, my a minus b will have to be equal to 20, which is not possible considering the limitations that we have on a on b. So this is something that we cannot accept. Also, if you want to go further in the other direction and check what if this whole thing is 0. Now see, 0 is a multiple of any number, so you'll always have to check for that. Okay, that will only happen when a minus b is minus 30. This is again not possible, and the reason it is not possible is because for that to happen, I'll have to have a number b which is greater than or equal to 13, which is not acceptable. So we have finally received two equations by the divisibility test of 11. So let's check for the divisibility test of 9. All right. Okay. So the divisibility test of 9 says that sum of all digits has to be a multiple of 9. What is the sum of all digits? It is 6 plus 2 plus a plus b plus 4 plus 2 plus 7. Okay. This comes out to be 8, 12, 14, 21 plus a plus b. Now we'll check for all the numbers that can help make me this number a multiple of 9. Let's see. The closest multiple of 9 near 21 is 18. But for that, a plus b has to be minus 3. Now this is not possible because both of these are whole numbers, right? So their sum cannot be negative. The other option can be 27, for which a plus b will have to be 6. And you can see that this is pretty acceptable, right? Because you can have a 1 and a 5, a 2 and a 4, a 3 and 3. All right. Third thing will be 36. And for that, a plus b has to be equal to 15. This is also quite possible because you can have a set like 6 and 9, 7 and 8, 9 and 6 again, if you take the vice versa. If you go further than this, that is where the problem starts. I'll have to have an a plus b equal to 24, which is again not possible under the conditions of a and b. So we have got two equations from the divisibility test of 9 as well. You can also notice that here also the values are different for a plus b, and that is only because they're representing different sets of values. So this can be like a 3 and a 3 or 4 and 2, but this will be like 9 and 6 or 8 and 7. So what we'll do on the next page, we'll solve these equations to find out what possible values of a and b we are getting. Okay. Okay, so we'll write all the equations that we have. So the first equation that we had was a minus b equal to minus 2. The second equation was a minus b equal to 9. The third was a plus b equal to 6. And the fourth was a plus b equal to 15. Alright. Now see, we cannot solve 1 and 2 together because they represent different set of values. Right? This cannot happen. And we cannot solve 3 and 4 together because they are different set of values. So what we can solve are 1 and 3, 1 and 4, 2 and 3, 2 and 4. Okay, let's see. My equation 1 was a minus b equal to minus 2 and a plus b equal to 6. Right? A simple addition of these two equations will actually give me the value of a. So if I add these two equations, I'll get a 2a, my b gets cancelled out, and the value that I come out to be is 4, which means my a is equal to 2. It perfectly satisfies my criteria that it is a whole number between 0 and 9. So if I put a equal to 2 in the second equation, I get b equal to 4. Both are satisfying my criteria, so I don't need to worry about that. These values are correct. But I have to check if there is another set of values that can satisfy this answer. So I'll start with equation 1 and 4. I'm getting a minus b equal to minus 2 and a plus b equal to 15. If I add these two values, I get 2a equal to 13 and a will have to be 6.5. See, now the property that we discussed, a cannot be 6.5, so these set of values are not correct. Let's look at 2 and 3. Okay, I have a minus b equal to minus, sorry, we have 2 and 3. Yeah, a minus b equal to 9 and a plus b equal to 6. If I add these two values, I'll get 2a equal to 15 and a equal to 7.5, which is again not correct. So the final set of values that I'll check would be a minus b equal to 9 and a plus b equal to 15. Adding those, I'll get 2a equal to 24 and a equal to 12, which is again not correct because the number has to lie between 0 and 9. So at the end of the day, we are getting just one set of values that actually satisfies all our criteria. So let's find out the final answer. I've got a equal to 2 and b is equal to 4, right? So let's put it into the final expression. Okay, so we have 950 multiplied with 2, 29 multiplied with 4 and a plus 1. This gives us 1900 plus 116 plus 1. If you all add all of that, you'll get 2017. Now, this is the year we are ending right now. So this is something that examiners do in Olympiad questions. They play on the year, so sometimes they put it in the question, sometimes they expect that as the answer. So it is kind of a verification that what you have done is correct. Anyway, so you don't need to worry because we have tested everything properly. So I hope that you've understood how to test for divisibility rules and how to solve simultaneous equations. Try it at home, try more questions, and best of luck. Thank you and have a happy new year.